Alright, here's the last section that we need to look at for this week, section 3.4. And we'll do one example together. There's only 4 total problems in here, and they're all very similar. They're trying to give you word problem types of examples that involve functions that are quadratic. And maybe not overtly so at first, but they definitely turn into quadratic types of elements. And so a very classic problem is what we'll have here in our example for this section. The price P in dollars and the quantity X sold of a certain product satisfies the demand equation, or satisfy the demand equation X is equal to negative 8p plus 400. And then it will ask some questions. And so X is the number of units sold, P is the price, and so as we raise the price, we sell less units. That makes a whole lot of sense, and so that's why the 8's negative. That as we increase in our price, we sell less units. And so there's a magic tipping point, right? And that's the whole business model that we have. And so the first question is, and I'll label it A, they will ask us to say, find a model that represents, or that expresses is the word that they use, the revenue R as a function of P. And they'll remind you that, and they actually put that, they put, remember, R, the revenue, is simply the number of units sold times the price. So the revenue that a company brings in, or for a particular product, is the number of units they sold at the price that they sold them. And so as you look at this revenue function, it's not of P, it's of both X and P. We need a revenue function all in terms of P. Well, how easy is that to do? Easy. So let's come in here. Let me come over here to my highlighter and highlight something in blue. There's our X in terms of P. So all that's needed to happen is we just need to take what, remember it's X times P. So what's X? X is negative 8p plus 400. Just to highlight what's being substituted in, times P. That is a revenue function all in terms of P. Now, I didn't type it in like that. I just wanted to see what it would accept. We really should see it like this. And this is why it's here. This is why it's part of a 2-3 combo, is because what we're dealing with is a quadratic function, right? We know a lot about this. This revenue function is parabolic in shape. It opens down, right? And we're going to use all of that. And so the next question that they're going to ask us is, well, what's the domain? And here's where we think, what is the domain of R of P? Which I'll remind you is equal to negative 8p squared plus 400p. Well, think about what P could be. Well, P's a price, so P has a lower bound. P will never be less than 0. You're not going to pay people to take your product. And you probably aren't going to give it away for free, but they will put a less than or equal to there. But then there is a price that tips it all out. You definitely don't want to charge more than a particular price, otherwise you're going to have negative revenue, right? So the question is, what is going to make this negative 8p squared plus 400p equal to 0? And you'll quickly figure out what that is. It's 50. If you're saying, well, how are you doing that, Jensen? Just set it equal to 0. And come back with me to Algebra 1. Let's factor out the greatest common factor, negative 8p. And we'll be left with p minus 50. Certainly you can see that this one's going to give us 0 and that this one's going to give us 50. Perfect. That's where the domain's coming from, because what's happening is an upside down parabola that has, it has some sort of maximum height, but it has 0 revenue here and negative revenue, if that makes sense, coming through there. But that's what we got. So we have that as our domain. Pretty nice. So we're using all of our algebra skills that we've developed over the time, right, in this new context. So how about C? What's C going to ask us? What price maximizes our revenue? Well, you know what this thing looks like. It's an upside down parabola. The revenue function is an upside down parabola, which means it has a maximum. That's why they're asking about a maximum. So all we have to do, what's this equivalently? Find the vertex. If that's the equivalent question, right? Think about your work in the previous section. You were trying to find the maximum value. Well, what were you finding? The vertex. So you know what to do. We need to take r of p, which is equal to negative 8p squared plus 400p, and go ahead and complete that square. No problem. What can we do to complete this square? Well, you know what we need to do first. We need to pull out the negative 8 and make sure you switch that sign in the middle. You need to take half of 50, 25, square it, 625, and add it in there. Realize that you added negative 8 times that, which is 5,000, so you need to add 5,000 out here. So how is that helpful? You just figured out that at 25, a price of 25 will maximize the revenue. And you actually can see physically what that maximum revenue is. You don't need a graph and calculator or anything like that. It's just sitting right in front of you. And so, let me answer C. Let me not skip D. Sorry, I'm getting old. It's cool. So this tells you that the price you should charge is $25. Because remember, where's the vertex of this parabola? It's at 5,000. Remember what this is. This is price, comma, revenue. So the price that you should charge is 25. Guess what D's going to ask? D's going to ask, what is the maximum revenue? Well, you don't have to do any more work. It's right in front of you. The max revenue is $5,000. That's the biggest revenue you're going to get out of this product. E, how many units were sold at this price? Well, you need to go to an equation that links number of units sold to price. Well, we were given that in the very beginning. Let's go right back up here and look at this blue highlighted equation. X is equal to negative 8p plus 400 would tell us how many units we sold at a particular price. And so X is equal to negative 8p plus 400. So X is equal to negative 8 times 25 plus 400, right? And so what are we going to get out of that? X is equal to negative 200 plus 400. So X is equal to 200 units sold. We sold 200 units in order to get that maximum revenue. And then they would have you choose the right graph. It's going to be pretty obvious which is the right graph. You'd be looking for a graph that went through 0 and 50 and was opening upside down, and there's only going to be one. That's not going to be hard. It's just a matching thing. But I thought it was interesting that they gave you G. What you will find is that we have a lot of respect for the math that you've already done. And so we don't typically reteach things. We just bring them up in context of other places. So here is the question. What price should we charge to earn at least $44,352 in revenue. This is who you are now. So this is loaded because they're using this word at least. We have to remember how we solved quadratic inequalities. What we need is for the revenue to be at least $4,352. Well, what's the revenue? Well, we had that equation. The revenue equation is right here. The negative 8p squared plus 400p. So the negative 8p squared plus 400p needs to be greater than or equal to 4352. Now you know how to solve quadratic inequalities, not because you learned it in this class, but because you learned it back in intermediate algebra. If you forgot, what we do is we get 0 on one side. So we're going to take negative 8p squared plus 400p and bring over the 4352 and have that greater than or equal to 0. If you remember, what to do next is you find out, you basically are going to go on a number line and you find out where this thing is flat out 0. So we'll do a little aside. We're going to need to figure out where negative 8p squared plus 400p minus 4352 is flat out equal to 0. Well, what's the first thing you should do? Divide everybody by negative 8. As you do, you're going to get negative 50, which you already knew. And 8 does go into 4352. It's going to make it positive. And using a calculator, right, I can't do that necessarily very easily in my head. I get 544. Now, you don't want to go to the quadratic formula. You're going to have huge numbers. Just think about the factors of 544. We need some that add to be 50. And as you play with some, 8 goes into it, 4 goes into it, 16 goes into it. And as you play around with it, you realize that it's a minus 16 and a minus, am I thinking about that right? Am I remembering that right? A minus 16 and a minus 34. Okay, again, just playing around with factors. If you multiplied that out, it would yield that, which means we have a 0 at positive 16 and at positive 34. And so these are where it's flat out 0. So we don't want it to be flat out 0. We want it to be greater than or equal to 0. And so what we do is we remember that it changes position in each one of these intervals. And as we plug in something like, what's something between, well, we just plug in 0. If we plug in 0 to this function, we get negative 4352. So we are negative here, positive here, and negative here. What do we need to be? We need to be positive. So hopefully that wasn't too fast. I am relying upon your old knowledge of solving quadratic and rational inequalities. There would have to have been a section in your intermediate algebra class. I apologize, not just a section, a chapter on this. It's important for us. And so they're just bringing this up out of the blue. And so, again, what I did is I tested a point in this interval. So remember, this is a big number line. So I tested the point 0, which is less than 16. 0 was easy for me to plug in here. And if I plug it into that equation, I get a negative number. And then we know it's alternating signs. So it's negative to positive to negative. And so we want it to be greater than 0. So the price that you should charge, and they'll have it set up this way, they'll have a maximum and minimum, is between $16 and $34. That would keep your revenue above $43.52. Okay, if you charge a price outside of that range, it's going to lower your revenue, at least lower than the $43.52. But pretty heavy concept just being dropped off in there. And again, don't get panicked about it. We use this as a time to remember and to ask questions. And so let me know what questions come up. But I wasn't anticipating this as the last part, but I'm glad we looked at this problem together. So use this as your guide for all the 3.4 problems.